Welcome back to the real number system. In this video, we're going to look at operations on decimals. So let's get started. First, let's talk about adding and subtracting decimals. Our base 10 blocks can be used to help with adding and subtracting decimals. When we use the base 10 blocks with decimals, typically a flat will represent 1 unit. A long will represent 1/10 of a unit because 10 longs make a flat. And a cube will represent 1/100th of a unit because 100 cubes make a flat. In example 1, we're asked to use flats, longs, and cubes to illustrate our addition. In part A, we have 2.48 plus 1.73. For 2.48, we have 2 units, so we have 2 flats. We have 4/10ths, so we have 4 longs. And we have 8/100ths, so we have 8 cubes. Then for 1.73, we have 1 unit, so 1 flat. We have 7 longs for the 7/10ths. And then we have 3 cubes to represent the 3/100ths. 2 flats plus 1 more flat makes 3 flats. 4 longs plus 7 more longs is 11 longs. And 8 cubes plus 3 cubes is 11 cubes. Now, earlier this semester, we talked about making exchanges. Remember that 10 cubes equals 1 long. So I'm going to take 10 of these cubes and exchange them for a long. That's going to give me 12 longs, and I have 1 cube left. Bring down your 3 flats. We also discussed earlier this semester that 10 longs make a flat. And so I'd exchange 10 longs for a flat, so that gives me 4 flats. I have 2 longs left, and then I have 1 cube. The 4 flats represent 4 units or 4 ones. The 2 longs represent 2/10ths, so I have a 2 in the 10ths place. And the 1 cube represents 1/100th, and so I have a 1 in the 100th place. And so my answer is 4.21. Let's look at another. In part B, we have 3.72 plus 2.39. For 3.72, we have 3 units, so 3 flats. We have 7/10ths, so 7 longs. And we have 2/100ths, so 2 cubes. To that, I'm adding 2.39, so 2 units or 2 flats, plus 3/10ths, so 3 longs, and 9/100ths, so 9 cubes. 3 flats plus 2 flats is 5 flats. 7 longs plus 3 longs is 10 longs. And 2 cubes plus 9 cubes is 11 cubes. I need to make my exchanges. 10 cubes is the same thing as 1 long. So I take 10 cubes and I exchange them for a long. That gives me 11 longs, and I have 1 cube left. Bring down your 5 flats. There are 10 longs and a flat. And so I exchange 10 longs for a flat. That gives me 6 flats. I have 1 long left, and I have a cube. 6 flats represents 6 units or 6 ones. 1 long represents 1/10th, so I have a 1 in the 10ths place. And 1 cube represents 1/100th, and so I have a 1 in the 100ths place. And my answer is 6.11. When we're adding and subtracting our decimals, we want to line up our decimals so that the like places can be added or subtracted together. Now, this is the same idea of using our common denominators when adding fractions. We add tenths to tenths and hundredths to hundredths, and so on. Look at example 2. In part A, the first thing I want to do is line up my decimal places. Notice that 2.6 has fewer decimal places than 13.41. In our last section, we stated that we could write a 0 after a decimal place, and it doesn't change the value of our number. So I'm going to write a 0 after that 6 so that I have the same number of decimal places in both of my numbers. Add your like places, so we add the hundredths. 1 plus 0 is 1. We add the tenths. 4 plus 6 gives me 10. Now 10 tenths is the same thing as a unit, so I make my exchange. I have a 0 in the tenths place, and I have an extra unit in the ones place. Add the ones place together. 1 plus 3 plus 2 is 6. And then add your tens place, and we get 16.01. Now let's look at part B with our subtracting. Again, first we want to line up our decimal places. Notice that 67.8 does not have as many decimal places as 28.32. So I need to write a 0 after the 8 to be sure my numbers have the same number of decimal places. Again, if I write a 0 after the decimal place, I haven't changed the value of the number. Then we subtract using the algorithm that we learned earlier this semester. Well, when I look at my hundredths place, I don't have enough hundredths to take away 2. So I make an exchange. I take one of my tenths and I exchange them for 10 hundredths. So 10 minus 2 gives me 8 in the hundredths place. 7 minus 3 is 4 in the tenths place. Now look at your ones place. I don't have enough ones to take away. So I take 1 10 and I exchange it for 10 ones, so that gives me 17 ones. 17 minus 8 is 9, and then 5 minus 2 is 3. And our answer is 39.48. Now, let's look at multiplying our decimals. One way to multiply our decimals is to write the decimals in fraction form and then multiply. So here's what this looks like. In part A, we have 4.62, and I'm multiplying that by 2.4. Well, 4.62 is 4 plus 62 hundredths, because we have the hundredths place in our decimal. Find a common denominator, which would be 100. 4 is understood to be 4 over 1, so when I multiply the bottom by 100, I need to multiply the top, the 4, by 100, and that gives me 400. 62 over 100 already has that common denominator, so I bring down the numerator. Now I can add my numbers together because they have the same denominator. 4 hundredths plus 62 hundredths gives me 462 hundredths. Now notice I had my hundredths place in my decimal, and my answer ended up being 462 hundredths. I can use the same concept with the 2.4. The 4 is in the tenths place, that last decimal place, and so we'd have 24 tenths. Multiply your numerators. I used my scratch paper to multiply 462 by 24, and I got 11,088. 100 times 10 is 1,000. I have 11,000 divided by 1,000 is 11, and I still have those 88 thousandths left, so that would be 11.088. Let's look at part B. We have 5 tenths times 3 tenths. Notice I went ahead and wrote my decimals as fractions. Multiply the numerators. 5 times 3 is 15. And multiply the denominators. 10 times 10 is 100. We have 15 hundredths, so that would be 0.15. Let's look at our algorithm for multiplying our decimals. Our algorithm for multiplying decimals says we look at how many decimal places we have in each of our factors, and we count the total number of decimal places in those factors, and that gives us the total number of decimal places in our final answer. So let's use the algorithm to multiply each of the following. In part A, we have 6.2 times 1.43. To make my multiplication easier, I'm going to write the longer number on the top. And then I multiply just like we learned earlier this semester. So I start with my ones place. 3 times 2 is 6. Move to your tenths place. 4 times 2 is 8. And then 1 times 2 is 2. We need a 0 to hold our place. 3 times 6 is 18, and I have to make that exchange. Don't forget about that 1. 4 times 6 is 24, plus 1 more gives us 25. Don't forget to make that exchange with your 2. 1 times 6 is 6, plus the 2 that we exchanged gives us 8. Then add. Notice my first number has 2 decimal places. My second factor has 1 decimal place. That tells me my final answer will have 3 decimal places. And so my answer is 8.866. Look at part B. We have 0.02 times 0.013. Write the longer number on the top and multiply. 3 times 2 is 6. 1 times 2 is 2. Now notice here, I have 3 decimal places in my first factor. I have 2 decimal places in my second factor. That gives me 5 decimal places. So I'm going to have to write some zeros to make sure I have my 5 decimal places. Notice I now have 5 decimal places, and so my final answer is 0.00026. Now let's look at scientific notation. With scientific notation, we have the product of a number, I'll talk about this number in a minute, and a power of 10. Now, our number has to be greater than, or it can be equal to 1, but it also has to be less than 10. If you have a negative number, we just put a negative sign in front of our notation. Let's look at how this works. In part A, we want to write this in scientific notation. My number needs to be between 1 and 10. So my number is going to be 4.13682 because this number is between 1 and 10. I'm going to multiply this by a power of 10 to write this in scientific notation. My power of 10 here is positive because my number is bigger than 1. Count how many times I had to move the decimal place so that the decimal place was behind the 4. So when I count here, notice there were 8 times that I had to move that decimal place. So my power of the 10 is a positive 8. Look at part B. We have 0.0000231. In scientific notation, I need a number between 1 and 10, so 2.31 is between 1 and 10. I'm going to multiply by a power of 10. Now notice here my power of 10 is going to be negative because my number is between 0 and 1. And I count how many times I had to move my decimal place to put it behind the 2. So when we count, we have to move that decimal place 5 times, and so my power of 10 is negative 5. Look at part C. We have 83.7. I need a number between 1 and 10, so that would be 8.37. I'm going to multiply by a power of 10. My power of 10 here is positive because my number is greater than 1. How many times did I have to move the decimal place so that it was after the 8? I only moved it 1 time, and so my power of 10 here is 1. Look at part D. We have a negative number in part D. We have negative 10 million. I need a number between 1 and 10, and it's okay for my number to be 1. And because we have a negative, my number is actually going to be negative 1 here. I multiply by a power of 10. My power of 10 is positive because my original number was greater than 1. And I count how many times I had to move the decimal place so that the decimal is behind the 1. We have to move it 7 times, and so the power of 10 is 7. Look at part E. We have 0.34 times 10 to the negative 6. Now I'll come back to that 10 to the negative 6. This number is not in scientific notation because 0.34 is not between 1 and 10. 3.4 is between 1 and 10. Then I'm going to multiply by a power of 10. Again, I'll come back to the 10 to the negative 6 here in a minute. how many times do I have to move the decimal place so that the decimal place is behind the 3? Well, we only moved it one time. And so my power of 10 is -1 because the 0.34 was between 0 and 1. Don't forget about that 10 to the -6. I have like bases, and so I add my powers. -1 plus -6 gives us 3.4 times 10 to the -7. Now let's suppose we have a number in scientific notation and we want to change it to a standard numeral. So if my power is negative, then I'm going to end up with a number between 0 and 1. In other words, I move my decimal place to the left. If my power is positive, I end up with a number greater than 1, and so I move my decimal place to the right. In part A, we have 6.84 times 10 to the -5th. So I'm going to write 684. My power is negative, so I move that decimal place to the left, and I'm going to move it to the left 5 times. It starts behind the 6, and I move it 1, 2, 3, 4, 5 times. And so my final answer is 0.0000684. Look at part B. We have 3.12 times 10 to the 7th. Now that 7 is positive. My power of 10 is positive, so I move my decimal to the right. So I write my 312, and then I move the decimal to the right. 1, 2, 3, 4, 5, 6, 7 times. And so my final answer is 31,200,000. Look at part C. Bring across that negative, and my number is 408. I have 10 to the 4th. That tells me I move my decimal place to the right 4 times. 1, 2, 3, 4. And so my final answer is -40,800. In the next video, we'll pick up with dividing decimals.